So, welcome to the second part of the one-way analysis of variance chapter. So in the last part, we talked about how to actually calculate the one-way analysis of variance to actually get the F statistic, which was this right here, the mean squares of the group divided by the mean squares within. Well, now we need to talk about what it really means. So if you remember, we've been discussing, I discussed the example last time of the advertisement with Jay-Z, Justin Bieber, and Beyonce. Those are the three groups. Let's say that I had a hypothesis that people would prefer Beyonce over Jay-Z and Justin Bieber. Well, if I get a significant F test, all it means is that there's a difference somewhere. I don't know if Jay-Z is, like more than Justin Bieber and more than Beyonce, or Beyonce is more than Justin Bieber, or Jay-Z, or both Jay-Z and Beyonce are better than Justin Bieber. I don't know. I don't know based off of that statistic. I have to run a secondary test. These are called pairwise tests. So if I want to figure out which ones are different, if it's Jay-Z that's different than Bieber, or Bieber that's different than Beyonce, or Beyonce that's different than Jay-Z, or any of those, right? I've got to run what's called a pairwise test. The pairwise tests are split up into two groups, a priori and post hoc. A priori means I was planning to do this before I did the test at all. And post hoc means I would have done this after I saw the results and wasn't really planning on it. Now, I mean, those get philosophically important, but for us, they're a little bit esoteric. So what we're going to learn today are a pairwise T-test and a Tukey Hsd. A pairwise T-test and a Tukey Hsd. So to show you how to do this, we're not going to do this at all on Excel. We're only going to do this in our studio. In fact, anyway, so I'm only going to ever do this. And what it is, remember, this is for us to figure out which means are actually different from each other, which groups are actually different from the other groups. So let's go ahead and go to some data. Okay, so to do this, I'm going to attach what we were looking at before. So I'm going to attach the data about skiing, snowboarding, and neither on the slopes. And I'll show you what it means again, just to remind you. This is my one-way ANOVA example. Okay, just to remind you what this looks like. Remember, I had 24 participants, and they either like to snowboard, ski, or do neither, right? And then I was measuring how much time they spend on the mountain. So let's go ahead and run the analysis of variance like we did before, just to remind you what it looks like. And then we will look at the different kinds of pairwise tests. We'll look at a pairwise T-test, and then we will look at a Tukey's Hsd, which is a post hoc test. So let's go ahead and start with this. So remember, here's my hypothesis. I think that snowboarders spend more time on the mountain than skiers or anybody else, right? I don't think there's any difference between people who ski and people who enjoy neither. I think it is snowboarders. Snowboarders are significantly more than everybody else. So in order to do this, I need to create a model, and I can name the model whatever I want. I'm going to name mine Bobo. Bobo the model. Bobo. And Bobo is going to be the analysis of variance. It's the same that we did last time. The analysis of variance, time on the mountain by sport. Now, if you remember, when we look at these data, we have to say summary of Bobo. And here's what I get. Let's make this bigger so you can see it. Okay, so this right here, this F statistic and this probability of that F statistic are saying, hey, there's a significant difference between those three groups. There's a significant difference between skiers, snowboarders, and neither, but it's not telling us what it is. So let's look at the means, just to remember. To do that, we do T apply, and then we do the dependent variable that we want, which is time on the mountain, comma, the independent variable, which is sport, and then we tell it what we want to know, and that's the mean. When we do this, it says the average time on the mountain for neither is 12.65 hours. The average for skiers is 12.90 hours. The hours for snowboarders is 13.54. So we have a pretty good idea that snowboarders and neither are significantly different, but we don't know if skiers are significantly different than snowboarders. That's when we have to run our pairwise tests. So if we were planning to do this from the beginning, then what we would run is, there's a couple of options, but we could run a pairwise T-test. So a pairwise T-test is going to say, I want to look at the difference between the means of each of the two. I'm going to separate these by two. So ski versus snowboard, that's going to be one test. I'm going to have neither versus snowboard, that's another test. Neither versus ski, that's another test that's going to happen. But we can't run this like a normal T-test. The reason why is because if we do that, then we're making some assumptions about the p-values which aren't quite right. We want to make sure that we're not giving too much emphasis on things and getting, not being strict enough in our pairwise test. So that's why we got to adjust the way we're going to do the pairwise. So what we're going to do is we're going to go ahead and give the dependent variables. We're going to write this in just like we did the t-apply, except we're going to add something called the p-adjust method. And I'll show you what that is in just a second. So I want to know a pairwise t-test based on the time on the mountain, comma, sport, comma, and then the p-adjust method equals. We have to adjust the way we get the p-values, because if we don't do this, we're not going to be strict enough in our p-values, right? It's likely that we would get these just by chance. So we got to adjust it. And the way we're going to do this, we're going to put it in quotes, is we're going to do Bonferroni. Bonferroni is an adjustment method. Oh, I always spell this wrong. Bonferroni. I think I did it right. Bonferroni. Let's see if I did it right. When we do this, this will adjust the way we do the p-values to be strict enough that we can actually have a little bit more reliability in what we're looking at. So here we go. I did it. I spelled it right. Good for me. So what you see here are the pairwise comparison using t-test with a pooled standard deviation, right? And what they're doing is we're adjusting the p-value based off of a method called Bonferroni. These are the p-values between ski and neither, right? So the amount of time on the mountain for skiers versus the amount of time on the mountain for neither, when you look at the t-test for that, the p-value of that t-test is 0.90. That's a lot more than 0.05. There's no significant difference between skiers and neither. So that means there's no significant difference between 12.65 and 12.90. That is neither versus skiers, okay? This is the p-value of neither versus snowboard, right? So neither, 12.65, versus snowboard, 13.54. The p-value of the t-test that compares those two means it's 0.0017. That means there is a significant difference. We can say that snowboarders spend significantly more time on the mountain than people who prefer neither snowboard nor skiing. When we look at this is the p-value between skiers and snowboarders. It is less than 0.05. What it's saying then is there's a significant difference between 12.90 and 13.54. So this is saying that there is a significant difference between snowboarders and everybody else, but there's no significant difference between skiers and neither. Now, if we didn't know that we were going to do that before, technically we should run something called a post-hoc test. Post-hoc test, there's, I mentioned on that slide, Tukey, there's also Hsd, there's other ones. I'm only going to show you Tukey Hsd. Hsd stands for honestly significant difference. So all we do for this one is write Tukey Hsd, and in parentheses we put our model. Remember I named my model Bobo? Here it is. This is now looking at the p adjusted. So here's the p values according to Tukey. So it's doing the same thing. Ski versus neither, the p-value would be 0.54. That's not significantly different. Snowboard versus neither, there is a significant difference. And snowboard versus skiers, there's also a significant difference right there. Okay? So we only use the pairwise test if there is a significant difference there's a significant analysis of variance. So only use the pairwise test if there is a significant analysis of variance. If that F test, the analysis of variance is represented by the F, if F is not significant, then you don't need to do the pairwise. You just don't need to do it at all. So here's what I want you to do. I want you to go ahead and run a pairwise T-test and a Tukey Hsd for the data that we had before, that we were working with before, which was the eyewear stuff, glasses versus contacts versus neither. Run both of them. Now in real life, you would only run one of them because you would either plan them before or you would do it after, right? But I want you to run both of them just for practice, and then you can talk about what it means. Okay, so what we're going to do then, I'm going to go ahead and detach what we've been working on, which is the one-way example for R. Now I'm going to attach the one that I want, which is the ANOVA example class, which if you remember, let's look at the data up here. ANOVA example class is, I've got people who either wear glasses, contacts, or neither, none, right? And let's go ahead and look at the difference that they have on their sleep. Let's see if there's a significant difference in sleep. If there's not, then we might have to do screen time here. So let's see what we've got. So let's create a model. I'll name this model, I'll name it Coco, because that sounds like fun. I did Bobo before, I'll do Coco now. I don't know why. Name it whatever you want, doesn't matter. I'm going to do an analysis of variance, and I want to look at the dependent variable of sleep by eyewear. When I do that, I have to do the summary of Coco. And this is what I get. Let's move this up so we can see. So this right here, this F value of 9.38, the probability of that happening by chance is 0.00123. So that means there is a significant difference between people who wear glasses, people who wear contacts, and people who wear none on how much they are sleeping. So I don't know what that is yet, though. I don't know which group it is. So I don't know which one is higher and which one is lower. Let's look at the means. T apply. Then we put in the dependent variable first, which in this case is sleep, comma, the independent variable, which is eyewear, comma, what we want it to tell us, which is the mean. People who wear contacts get 5.75 hours of sleep. People who wear glasses get 7.5 hours of sleep. People who wear none get 5.25 hours of sleep on average. Now, at least one of these values is significantly different than the other, or it could be more than one, we don't know. So we have a pretty good guess that glasses is probably going to be significantly different than none, but we don't know if contacts is significantly different than glasses, or if contacts is significantly different than none. We have a good guess, but we're not sure. So let's run a pairwise T-test first. A pairwise T-test, we put in the dependent variable, which is sleep, followed by a comma, and the independent variable, which is eyewear, followed by a comma. Then we need a P adjust method equals. P adjust method equals. In parentheses, we got to write Bonferroni. Bonferroni. Make sure you spell it right or else it won't know what you're talking about. Let's see if I did it right. I did it. Look for me. Look for me. I'm just excited. All right, fine. These are the P values of the T-test between glasses and contacts. So glasses and contacts are significantly different. Let's look at those means. Glasses and contacts, 7.50 is significantly different than 5.75. The difference between none and contacts, whoa, 1.0. That's like the farthest you can get from 0.05. Contacts and none, Look, no significant difference. Contacts and none. 5.75 is like not at all different than 5.25. Okay, glasses and none are significantly different. So what this is saying is people who wear glasses sleep significantly more than people who wear contacts or people who wear none. But people who wear contacts, people who wear none, they're not different at all from each other. Now let's run Tukey Hsd. Tukey Hsd is easy. I'll just put the name of the model in it, and that is Cocoa. When I do that, here's what I get. Glasses versus contacts, the p-value is right there, p-adjusted right there, that's what we're looking for. The difference is significant. None in contacts, that's not significant. None in glasses, that is significant. The same information. And when we look at the means, we know that people who wear glasses are sleeping significantly more than people who wear none or people who wear contacts. They sleep significantly more. Okay, thanks everybody.